Why Russian enemies are afraid of this MiG-31 Super Interceptor. The MiG-31 Foxhound is a two-seat, long-range supersonic interceptor aircraft made available by Russian Aircraft Corporation, formerly Mikoyan and MiG, primarily for the use of the air forces of Russia and Kazakhstan. In September 1975, it made its first flight. Modern digital avionics are featured in the MiG-31 aircraft, which was developed from the MiG-25 Foxbat interceptor. The MiG-31 can operate effectively in all weather, adhering to both visual and flight rules and instrument flight regulations day or night. The MiG-31 was the first Soviet fighter jet to truly have the capacity to look down and shoot down an opponent. Want to know more? Well, hey guys, welcome to our channel Future Warplanes, where we tell you about military fighter jets, military drones, military planes from the currently famous in the air to the most advanced around the world, and, in addition for the latest episodes, we will be covering all military defense news. So stay with us till the end of this video so you don't miss out on any of this information. And before we proceed, don't forget to subscribe to our channel and click on the bell icon so you don't miss out on any of our amazing videos in the future. The MiG-31, also known by its NATO codename Foxhound, gained some mystique in the West during the final decade of the Cold War. In aviation magazines, the high-speed fighter would be depicted in the same hazy aerial images coupled with menacing speculation about its capabilities. But unlike its contemporaries, the MiG-29 and Su-27, the Foxhound never truly came out of the shadows after the Cold War. The MiG-25 Foxbat, the Foxhound's forerunner, was a bit of a letdown, and this was an attempt to improve on it. As a means of fending off American aircraft, the twin-engine Foxbat, capable of reaching speeds above Mach 3 and flying up to 70,000 feet, continues to be the fastest fighter in use. The supersonic bomber XB-70 Valkyrie was intended to be produced, but it was never done. The Foxbat had a high reputation in Western aviation circles until Soviet defector Viktor Belenko flew one to Japan in 1976, revealing to the Pentagon what the Soviets had known all along, that for all its speed, the Foxbat was a bit of a dog when it came to maneuverability and could not maintain supersonic speeds at low altitude. Furthermore, it could only reach Mach 3 speeds by overheating its engines to the point of failure. 370 MiG-31 aircraft were supplied to the Russian Air Force, while 30 are currently in use by the Kazakhstan Air Force out of the more than 500 MiG-31 aircraft that have been constructed. The remaining aircraft were modified into various types as part of several upgrade programs. Only a small portion of the Russian MiG fleet has undergone the MiG-31 BM upgrading program. In July 2020, the Russian Defense Ministry declared its plan to invest in a program to modernize and extend the life of MiG-31 Foxhound interceptors. Two agreements totaling around $1 billion were made between Syria and the United Aircraft Corporation of Russia in 2007. Both a MiG-29M and a MiG-31 were covered under separate contracts. The MiG-29M deliveries are still going on, but the MiG-31 deliveries didn't start until 2009, when the UAC confirmed that it would be sending 8 MiG-31 planes to Syria as part of the $1 billion contract. In an agreement worth $400 million that was inked in 2007, 8 MiG-31 aircraft were ordered. Israel's pressure and a lack of cash caused the order to be canceled in May 2009. Flying at low altitudes was impossible for the MiG-25 Foxbat. A decrease in combat range at supersonic speeds was caused by the installation of inefficient turbojet engines, and the MiG-25's engine was destroyed as a result of an increase in speed gauge readings. The MiG-31 was created to fly at low altitudes with required supersonic speeds in an effort to overcome the limitations of the MiG-25 Foxbat. A longer combat range is possible with the MiG-31's effective low bypass ratio turbofan engines. In 1982, the MiG-31 had completed production and was fully operational with the Soviet Anti-Air Defense, or PVO. Many units in the USSR are finding it challenging to maintain their intricate MiG-31 aircraft due to the country's economic slump. The outcome was that 20% or so of the MiG-31 aircraft were retired from service, but in 2006, when robust economic recovery resumed, about 75% of these aircraft were put back into service with the Russian Air Force. To permit flying at high speeds at low altitude, the MiG-31 has a highly aerodynamic and streamlined body. The plane was built to follow several targets at once while flying at great altitudes. The airframe of the MiG-31 is made of a variety of materials, including titanium 16%, aluminum alloy 33%, and 2% composites. Welded nickel steel accounts for 49% of the aircraft's composition. The fuselage of the aircraft also has 4 underwing pylons installed. The fuselage of the aircraft has a bubble canopy with a long pointed snout, and it's meant to have lateral, rectangular, and diagonal cut air intakes. With square tips and a downward slope, the wings are swept back and sharpened. By launching the Aerospace Rally System rocket-powered suborbital glider, the commercial satellite launch variants MiG-31A and MiG-31S have been used to train astronauts, carry out upper atmospheric research, and promote space travel. An upgraded version of the supersonic interceptor MiG-31 is the MiG-31E. It measures 21.6 meters in length, 13.45 meters in wingspan, and 6.45 meters in height. The airplane weighs 21,825 kilograms when it is empty. The Airborne Phased Array Radar RP-31E is a feature of the MiG-31E. It can track 10 targets at a distance of a few kilometers and eliminate 4 of them. The MiG-31E has the ability to annihilate airborne targets flying in the front and rear hemispheres at altitudes between 50 meters and 28,000 meters in both favorable and unfavorable weather conditions. The MiG-31E aircraft searches the airspace with a width of 900 to 1,000 kilometers in the absence of a ground air defense system. In the passive mode of a blind attack, an infrared seeker unit mounted in the version can track targets by its heat output. Digital avionics like as MFDs and liquid crystal displays are installed in the MiG-31 cockpit and give real-time instrument readings and radar data. Zero ejection seats are installed on both the front and back sides of the cockpit, enabling the pilot to fly at the selected height and airspeed. The weapon system officer, who controls the radar operations and weapon deployment, sits at the rear cockpit seat while the pilot occupies the front seat, reducing the pilot's workload and maximizing efficiency. In the MiG-31 aircraft, there are 4 long-range Vempel R-33E air-to-air missiles. When the target's far away, the R-33 can be launched in inertial navigation mode. For initial acquisition and mid-course updates, it can be directed in SARH mode or semi-active radar homing. The SR-71 Blackbird, the B-1 Lancer Bomber, and the B-52 Stratofortress are just a few examples of the kinds of massive, swift targets it can take out. 4 R-60MK missiles for short range and 2 Biznavat R-40TD-1 missiles for medium range are also mounted on the aircraft. Above the starboard, main landing gear bay of the MiG-31 aircraft is a 6-barrel 30mm internal gun. Over 10,000 shots may be fired from the cannon per minute, and it has an ammunition capacity of 800 rounds. The Russian air-to-ground missiles, including the AS-17 Krypton anti-radiation missile and the AA-12 Adder missile, can both be carried by the MiG-31BM. And the MiG-31 aircraft is equipped with the first electronically scanned N007 Zaslon phased array radar in the world. It's also referred to as SBI-16 Zaslon or Flashdance radar, and is controlled by WSO from the rear cockpit. It's capable of receiving signals from aerial warning and control systems and early warning radars. And that's going to end today's episode. We hope that you enjoyed our video. Please make sure you subscribe and leave a comment down below your own thoughts. And don't forget to like today's video. And we'll see you next time. Thanks for watching.